Welcome to our deep dive, everybody, into encapsulation.
Oh, this is a good one.
Yeah, it's something that, we hear about all the time,
Right.
especially in the context of, keeping your code organized, keeping it secure.
Absolutely.
It's more than just a security measure, though.
Oh, for sure. For
It
sure.
really is I don't know, like a blueprint for building,
It's a design philosophy.
yeah, robust and adaptable systems.
Absolutely. Yeah. And it all comes down to, setting up these checks and balances
Checks and balances, I like that.
within your code, right?
Yeah.
So you're basically creating these rules that govern how different parts of your program can interact with your data.
Okay.
And that level of control is just crucial, especially as your code base grows in complexity.
I mean, it sounds interesting, but is there any impact on, like, performance?
That's a great question.
Like, I mean, if you're hiding all the data all the time,
Right, right.
is that not inefficient?
So while there might be a tiny, tiny performance overhead in some cases,
Okay.
the benefits that you get from encapsulation
Mm.
far, far outweigh any kind of negligible performance dips you might encounter.
Gotcha.
Right. Because remember, encapsulation is all about preventing errors,
Right.
making your code more maintainable.
It's a long-term investment.
Exactly, in the long run. So it saves you tons of time debugging and refactoring down the road.
Yeah, no, I mean, that makes sense.
Yeah.
So encapsulation is all about control and security. We've kind of established that.
Right.
But how does it actually work?
Yeah.
Like, what are the building blocks of this whole concept?
So it really boils down to three key principles:
Okay.
private attributes, public methods, and class bundling.
Okay, let's unpack those a little bit.
Yeah, for sure.
So private attributes, public methods, class bundling.
Yeah, so think of it this way.
Okay.
Private attributes, these are like the crown jewels of your code.
Okay.
This is the data that you really want to protect. And they're declared as private, meaning they can only be accessed from within the class itself.
So like top secret files.
Exactly.
Like nobody can get to them.
Locked away, yeah.
Okay, all right, I got it.
All right.
What about public methods?
So public methods are kind of like the gatekeepers to those
Wow.
private attributes.
Right.
So they provide this controlled way to access and modify the data.
Okay.
And they ensure that everything happens according to the rules that you've set, right?
Guess they're like the guards of the vault?
Yeah, exactly.
They could open it up, but only if I have the right credential.
I got it, yeah.
Okay.
You got it.
Where does class bundling fit into all this?
So class bundling this is the vault itself, right?
Okay.
This is the concept of packaging all those private attributes and public methods into a single self-contained unit. The class.
So the class is the blueprint.
Yes.
And encapsulation is basically controlling access to the rooms within that blueprint.
Exactly. Precisely. And within those public methods, we
Yeah.
have things called getters and setters.
Getters and setters, okay.
Which allow us to retrieve and modify the values of those private attributes.
Now, are there any cases where breaking encapsulation is okay?
That's a good question.
Or is that like a cardinal sin?
So there might be some very, very specific edge cases
Okay.
where you might need to break encapsulation,
Okay.
maybe for performance reasons or to work around limitations in a framework or a library.
Okay.
But in general,
Uh-huh.
it's best to treat encapsulation as a golden rule.
Like, don't break the rules unless you have a really good reason.
Yeah, exactly.
Okay, I see. So we've covered the basics of encapsulation.
Right.
Protecting data, preventing errors, making our code adaptable.
Right?
But how does this actually translate into code?
Yeah,
Like, I'm sure our listeners are curious to see how this works beyond just the analogies.
absolutely. So let's look at a practical example.
Okay.
Okay, so let's say you're building a system that handles user data. Okay, something like a social media platform or an e-commerce website.
Uh-huh.
And you want to protect sensitive information like passwords or credit card details.
Oh, yeah, absolutely. That's critical these days.
Extremely critical. So you would create a user class,
Sure.
right, that encapsulates all the user's data.
Right.
And the attributes for things like passwords and credit card numbers would be marked private,
Right.
meaning they can only be accessed or modified through specific public methods within that user class itself.
So even if another part of the system needs that data,
Right.
it can't just grab it. It has to go through the proper channel.
It has to go through the proper channels. Exactly.
The public methods you've defined.
Exactly. And that way you can enforce very strict rules, validation checks,
Right.
to make sure that data is always handled securely and correctly.
So it's not just about hiding data. It's about creating this controlled environment
It's about creating a very controlled environment. That's exactly right.
where you dictate how it's accessed.
You dictate how it's accessed, how it's manipulated, absolutely. And this approach has this kind of ripple effect throughout your entire code base, right?
Right.
Because by breaking down your system into these well-defined encapsulated units,
Right.
you create a much more organized and manageable structure.
Like building a house with sturdy walls and doors.
That's a great way to put it, yeah.
I can control who comes in and who comes out, and you can prevent anybody from messing with the foundation.
Exactly. And this modularity, it also makes your code more reusable
Oh, so it helps with code reusability too.
and easier to maintain in the long run.
That's an added bonus.
Yeah, absolutely. And it's actually a fundamental aspect of object-oriented programming.
Yep.
Because by creating these reusable, self-contained units of code, it allows you to build much more complex systems much more efficiently and effectively.
This is really fascinating.
Yeah.
We've kind of covered the basic principles here
We've laid the groundwork.
and even touched on some real-world applications. Yeah, absolutely.
What else can our listeners expect in the next part of our deep dive into encapsulation?
So we're going to delve a little deeper into the mechanics
Okay.
of how encapsulation is implemented in code.
Okay.
We're going to look at specific examples of access modifiers, getters, setters,
Awesome.
and how they work in different programming languages.
Sounds like we're just getting started.
We're just getting warmed up.
So join us next time as we unlock even more secrets of encapsulation.
I can't wait.
All right, see everybody next time.
See ya.
Welcome back to our deep dive into encapsulation.
Yes, part 2.
Last time we were talking about encapsulation as a blueprint
Right, a design philosophy.
for building those robust systems and
For sure.
adaptable systems. And
Yeah.
we talked about those core principles, right?
We did.
Private attributes, public methods,
The all-important class bundling.
and the class bundling.
Yes,
It's all about those checks and balances in our code, right?
that's the key.
I'm ready to see this in action.
Okay, yeah. Can we look at some code examples
Absolutely.
to kind of illustrate these principles?
Yeah, let's revisit our user class example.
Okay.
Remember we talked about protecting that sensitive information?
Passwords, credit cards.
Yeah, passwords, credit card details, exactly.
Those need to be under lock and key.
They do. So let's actually see how that looks in code.
Okay.
All right, so here's a little snippet.
Okay.
All right, so we have a public class user.
Uh-huh.
And then we have, you can see there are private attributes.
Okay, so we've got username, password, credit card number,
Username, password, credit card number, all declared private.
all declared private
So they're hidden.
to keep them hidden.
Exactly.
Nice.
And then notice we have the set password method.
Okay, the set password method.
And it's public, so other parts of the system can use it,
Right.
but it has a validation rule built in.
So the password has to be at least 8 characters long.
At least 8 characters long, that's right.
There's our checks and balances.
Checks and balances in action, that's
Yeah.
right.
Like it. Okay.
And then we also have a get username method
Okay, to retrieve the username.
to retrieve the username, but there's no get password method.
So you can see the username, but not the password.
Exactly.
Interesting. Okay.
And then we have this authenticate method,
The authenticate method.
which
Okay.
allows you to check if an entered password actually matches the stored password
Okay.
without actually revealing the stored password itself.
Oh, that's pretty neat.
Right.
You can verify it without compromising.
Without compromising the security, exactly.
I like that. All right.
Okay, so now let's imagine you're building an e-commerce site
Okay.
and you need to store and process credit card information securely.
Right.
So your user class could have methods like set credit card number
Right.
and process payment.
Okay.
But again, the actual credit card number would stay private,
Stays private.
accessible only within the user class.
So you're creating a secure pathway
You're creating this pathway.
of this sensitive information.
That's right, while keeping the actual data tucked away safely.
All right. I like it. Okay.
So this brings us to access modifiers,
Access modifiers. Okay.
which dictate the visibility and accessibility of members within a class.
Okay.
So we've been focusing on private and public,
Private and public.
but there's also protected,
Protected. Oh, now.
which comes into play when we talk about inheritance.
Inheritance. Okay. This is where it gets a little bit more interesting.
Yeah, it gets fun.
So inheritance is about building upon existing code, right?
That's right. It allows us to create new classes that inherit properties and methods from existing classes.
Okay.
And protected members give us a way to control access within that inheritance hierarchy.
So you can pick and choose what to expose to the subclasses, but keep it hidden from the outside world.
That's a great way to put it, yeah.
I like it. Okay.
So let's say our e-commerce site needs to distinguish between regular customers
Uh-huh.
and premium members who get those extra perks.
Right, okay.
So we could create a premium user class that inherits from the user class.
Right. We might want to give premium user access to certain methods or attributes of user
Okay.
without making them public to everyone.
Right, okay.
That's where protected comes in.
So it's like a special key
It's like a special key, yeah.
just for those premium users.
Exactly.
Okay.
And this concept of inheritance combined with encapsulation, this is incredibly powerful
Okay.
because it lets you build these complex systems in a modular and organized way.
Right.
So you create this hierarchy of classes
Yeah.
that mirrors the real-world relationships between objects.
That's really cool.
It is, it is.
So by using encapsulation and inheritance,
Yeah.
we can build these systems that are not only robust and secure,
Right.
but also adaptable and much easier to maintain.
Absolutely. And these principles aren't limited to any specific programming language.
Oh,
Whether you're working with Java, Python, C++,
right.
any object-oriented language, these concepts are fundamental.
So it's not just a good practice.
It's more than a good practice. It's a foundational principle
It really is.
that can change the way we write and think about code.
Exactly. It's like moving from building with blocks to constructing with prefabricated modules.
Okay.
You're working at a higher level of abstraction, and that's incredibly empowering.
I like it. So we've covered a lot of ground
We have.
in this part of our deep dive.
You've gone deep.
What can our listeners expect next as we wrap up encapsulation?
So we'll explore some of the more nuanced aspects of encapsulation,
Right.
like interface-based design and how it relates to polymorphism.
Ooh, interface-based design, polymorphism.
That's right, the fun stuff.
All right, I'm eager to hear all about that, so join us next time as we complete our deep dive.
See you then.
Welcome back to the final part of our deep dive into encapsulation.
Yeah, the grand finale.
We've explored those core principles.
Right.
We've seen how it works in code.
Yes.
We even touched on inheritance a little bit.
We did.
But now it's time to bring it all together and see how encapsulation really elevates our software design.
Absolutely. So we're moving from the nuts and bolts
Yeah.
to the architectural elegance of it all.
Okay, I'm intrigued. What makes it so elegant architecturally?
So think of it this way, encapsulation.
Okay.
It isn't just about protecting data within a single class.
Right.
It's about creating a system
Uh-huh.
where objects interact with each other in a predictable and controlled manner.
So it's like setting up a communication protocol
Exactly.
for your code, making sure everything can talk to each other without breaking things.
You got it. And this is where interface-based design comes in.
Okay, interface-based design. That sounds interesting. What's
Yeah.
that all about?
So an interface,
Okay.
it defines a set of methods that a class must implement.
Okay.
It's like a contract that says, if you want to play in this system,
Blah.
you got to adhere to these rules.
So it's setting up expectations.
Setting expectations.
Ensuring compatibility
Exactly.
between different parts of the code.
Yeah. Exactly. And this leads us to
Okay.
polymorphism,
Polymorphism.
which is one of the most powerful concepts.
That sounds intimidating.
It's not as complex as it sounds.
All right.
Polymorphism just means many forms.
Okay.
In programming, it means that objects of different classes can be treated as objects of a common type.
Can you give us an example of that?
Sure, let's imagine you're building a system that processes payments.
Okay, payments, yeah.
Right, and you might have different payment methods.
Credit cards, PayPal.
Yeah, like credit cards, PayPal, bank transfers.
Right, and each one has its own logic for processing those transactions.
Exactly. So you could create separate classes
Right.
for, let's say, credit card payment,
Okay.
PayPal payment, bank transfer payment.
Okay.
But they all share that common goal
Of processing a payment.
of processing a payment, right?
So we could set up an interface.
You could define an interface.
We'll call it payment processor.
Let's call it payment processor, yeah.
That says, here's how you process a payment.
Exactly. It outlines the methods.
Right.
Required for processing a payment regardless of the specific method.
Right.
So each of your payment classes would then implement this payment processor interface.
Okay.
So they all have the necessary methods like process payment, refund payment, and so on.
And that's where the polymorphism comes in?
That's where the magic happens, right?
Okay.
Because all these payment classes implement the same interface.
Yes.
You can treat them interchangeably as payment processor objects.
Okay.
So you can write code that works with any payment processor
Right.
without needing to know the specific type of payment being processed.
So you've created this really adaptable system
You've built in that flexibility.
that can handle all these different types of payments Without having to write all these conditions.
Exactly. And the beautiful thing is,
Yeah.
if you need to add a new payment method later on,
Like Apple Pay or something like that.
like Apple Pay, you just create a new class that implements that payment processor interface.
Okay.
Your existing code doesn't need to change.
Doesn't need to change.
Because it's already designed to work with any object that adheres to that interface.
So you're future-proofing it.
You're future-proofing your code, exactly.
By making it open to extension but without modification.
That's it.
That's really cool.
That's the elegance of encapsulation and interface-based design.
Yeah.
They allow you to build these systems that are not only robust and secure,
Right.
but also adaptable and maintainable.
So encapsulation, it's more than just hiding data.
It's a design philosophy.
It is. It's a whole way of thinking about code.
It promotes modularity, flexibility, code reuse.
Yeah.
It's about thinking in terms of well-defined objects that interact with each other in a controlled and predictable way.
And that's the key to building truly elegant
I like it.
and maintainable software.
Absolutely.
Well, this has been an amazing deep dive into encapsulation.
It has been a journey.
We've covered a lot of ground.
We've gone deep.
From the basics to some really, I think, pretty advanced concepts.
Yeah, we've covered it all.
And hopefully, you've gained a much deeper appreciation
A deeper understanding.
for this power and elegance of encapsulation.
That's the goal.
Absolutely. It's one of those fundamental concepts that every programmer should really understand.
It's essential.
And really, it's a journey of continuous learning and exploration.
It is, for sure.
So keep coding.
Keep coding.
Keep experimenting.
Keep experimenting.
Keep pushing the boundaries of what's possible
That's what it's all about.
with software.
Absolutely.
Well, thank you for joining us on this deep dive into encapsulation.
It's been a pleasure.
We'll see you next time on the Deep Dive.
See you then.